So this is Appyters. We're going to be essentially what Appyters does, it turns Jupyter Notebooks into data-driven web applications. And it does this with three technologies, Jinja, Jupyter, and Flask. And I will kind of give you background about this and also the history of the project before I get into how you build one. So this is what we're doing. We're going to look at the background of these technologies, the history of harmonized ML, which eventually became Appyter. Then we're going to look at how you kind of develop an Appyter, and we'll go through and make our own Appyter with the harmonized ML Jupyter Notebook as a demonstration of how you turn a notebook into an Appyter. We'll discuss a little bit about how to get like customized form elements with the Appyter, and finally the kind of talk about the web catalog of Appyter, which you guys will probably be contributing to, many of you. So kind of the background here, I'm going to talk about a few technologies. To start with is Jupyter Notebooks, if you haven't heard about it already. This supports Markdown Text Descriptions, code, and plots all together in one thing. So you can kind of see this here, where we have some text describing what it is, some code that does the actual operation, and then the actual output plot. A lot of people like this a lot because it lets you do things like data analysis while fully describing it and producing the figures all at the same time. You get a lot of like reproducibility and transparency built in. So if you build a paper or something, you can include the Jupyter Notebook as a supplemental document, and people can reproduce your analysis. And there's a lot of like related tools for Jupyter because a lot of people like it. There's Colab by Google, which lets you run a Jupyter Notebook in the cloud. There's Binder, which lets you host a Jupyter Notebook and let other people run it, also in the cloud. I don't know what company makes that one. And then there's Jupyter NV Viewer, which just holds the like static output of a Jupyter Notebook, so that people can look at it, but they won't be able to run it. There's this other technology, Jinja 2. This is a widely established template language that really came out of Python's Django, which is a framework that was a lot more popular a little while ago, still used today. And Jinja 2 was extracted out of that, and a lot of other people in other languages have also used this template language or some minor variation of it. It looks somewhat like this. Typically, it's used to render HTML. So in here we have like an unordered list tag, and then you can do this flow control like a for loop. With some object that you provided. You can have some if statements, if else, and you can substitute variables using these like curly braces. And so it's kind of straightforward language to use once you've used it for a little. And that's Jinja. So then we also have Flask, which is a Python web development platform. This kind of brings together other tools, including Jinja 2, and kind of this WSGI backend that lets you run this HTTP servers on like better HTTP servers. So when you're running a Python application on the web, Python is not really designed to handle massive amounts of traffic, but these WSGI backend kind of enables that to happen by setting up multiple threads for your Python and making sure that things are secure. And then it does that with it's dangerous, some string sanitation, and Flask is pretty nice because it's pretty simple and has a ton of extensions. Here's kind of the most basic Flask application. Like this is how you set up Flask. It's like 2 lines. And then you can just route like the path. So here we have like, slash repos, for instance. You could do route / repos to this function. And so by returning hello world here, if you were to visit this web server, you'll get hello world. If you visit some value in the path, it'll end up at this route, which is a parameterized function, and then the argument will end up being provided. So, of course, there's lots more features, but just a quick look at Flask. Another technology that we take advantage of here and a lot in the lab, you'll mostly also be using it, is Docker. And the idea behind Docker is containerization. So unlike, say, a virtual machine where you run an entire operating system along with your application on top of a hypervisor, the containerized applications are a lot cheaper. They don't require the entire operating system. You can essentially reuse the host operating system and run applications on Docker while still being able to provide all necessary dependencies, even if they're like system libraries. And so that's what Docker does, and you can use this Docker Hub to store your applications and pull them elsewhere. And there's also this Docker Compose language, which lets you have multiple Docker applications and you can network them together. Here's kind of what a Docker file looks like. You can start from some base, install like system dependencies on your base and describe like what files you need on that Docker system. And then there's a simple command, docker build, to run this and construct your Docker system. Then Docker Compose looks something like this. It's a little small, but just for illustration that you have some application and you can describe the ports that it exposes and the image that it's using. So each of these refers to a Docker file. Docker is also nice because there's a bunch of things like databases that are already Dockerized. So you could spin up databases left and right with Docker. Another thing I'll just share real quick is Visual Studio Code. It's an editor that I personally like. There are alternatives, but if you're unaware of what IDE you should be using, this is one to try. It has kind of support for every programming language that I know of, and more through extensions. It has Git, Docker, and Jupyter integration, among other nice features. Now we'll talk about some of our apps. The Harmonizome ML project came out of Harmonizome, which is basically our most popular resource. As you can see, we have almost more than 28,000 users just in May, and we have tons of data in here from 66 major biomedical research resources, and we essentially just convert the data into a very easy to use, ready for machine learning format that looks like these. You have attribute, gene, and gene attribute. So that means you're saying that this gene is related to some attribute. Let's say it's a phenotype, or it's a anything. Structural features, cell lines. So this gene is exhibited in some cell line, things like that. And ultimately, this matrix is just a lot of information that you can use for training machine learning algorithms, among other things. This came out from previous people in the lab, and still is active today. And we have BioJupys, which is a very similar thing to Appyters, but it's kind of a little more constrained, and it revolves around RNA-seq data analysis. You can bring your own data, choose your analysis steps, and then BioJupys will produce a Jupyter Notebook with all the steps. It'll have like data normalization, visualization, as you can see here, and then like enrichment analysis. And that was built by Dennis, who was in the lab not too long ago. Yeah, so that's BioJupys. And now I'll kind of proceed with the Appyter history. Essentially, Harmonizome ML, again, for Harmonizome, the idea here was that because we know that this data is all ready to use for a machine learning problems, then you can essentially design a machine learning problem on the fly with the Harmonizome data. You can allow people to determine what are they going to provide, what do they want to predict, and then they can choose from the Harmonizome data relevant like data sets to use for the training data, for the test data, since the different types of data in Harmonizome are better used for either training or testing. Some of them are just really labels, while other of them are like omics data, really rich for machine learning training. And then we would also allow you to just choose some arbitrary off-the-shelf machine learning algorithm from scikit-learn and maybe a few others, your evaluation criteria, and then we would just construct a Jupyter Notebook for you. But throughout the course of this project, we understood that user input really can't be trusted if we're going to be constructing these Jupyter Notebooks on their input, their genes. We need some field validation. It also turns out that machine learning on large data sets in the Harmonizome can be slow. And so what we had to do was think about a way we might be able to do a streaming notebook evaluation so that we can actually show you results before it's ready. And we also knew that we would likely update this notebook later on as the data changed or as we wanted to come up with a better analysis or add new support. And so what we did was we decided to use the notebook itself as the data model of the application, and then use Jinja to render the form that users would use to build the notebook and the notebook itself. Of course, this was somewhat, naive at the start, and it was a little hard to debug these notebooks, but that was fixed with some this Jupyter magic that allows us to essentially run this in real time and use this Jinja in Jupyter feature as we're building the notebook. Yeah. And so then, in the spring, not too long ago, we looked at Harmonizome ML let's try and render with Harmonizome ML. And her notebook had something slightly different. Instead of using the Harmonizome data, she wanted people to just upload their own data. So we went ahead and just implemented an upload feature so that we could upload the data and then render the notebook using the uploaded file. And we realized that, wait, this is really useful for all types of other things. So we gutted Harmonize and ML, and that's kind of how we got Appyter. So Appyter is really just this idea that, okay, we're going to use an arbitrary Jupyter Notebook and build an entire web application out of it. We made some improvements to how it worked. We're using like Socket.io for streaming and uploading, and for like hot encoding, hot reloading, so that if you change something, we can refresh the page. And then we also made it a little prettier. It originally looked like this. Then we kind of adopted the BioJupy style, and these are provided in these profile overrides. So we can just add these profiles to the Appyters project, and then nothing has to change with the notebooks. It'll just get prettier. There are some alternatives for this that other people have made that are not quite the same, but I thought it made sense to list them. So there's something called Bokeh, which claims the interactive visualizations in Jupyter Notebooks. These are like, they allow you to actually, in your Jupyter Notebook, you can modify the variables so that the plot will change. There's My Binder that we mentioned before that allows you to run a notebook online yourself. There's NB Interact, which lets you publish notebooks as a web page, very similar, but it builds these interactive plots. Specifically, it's designed for, you built a notebook with interactive plots, and now you want to export it as a web page, but it wouldn't support things like actually adding new data. And then Voila is similarly, it will publish a regular Jupyter Notebook as a web page. Again, no prior solutions really allow you to programmatically alter it with like Jinja, as we're doing, or really to run Notebook with your own data, which is what we have Appyter for. Again, like a lot of these other things can actually be used with Appyter. We're looking into maybe using Appyter and rendering it on My Binder, but we can already definitely build these interactive plots and use them with Appyter. So let's get started. This is how you would actually set up an Appyter. If you're inclined to try it yourself, feel free. I will definitely share this after the talk as well. But first things first, definitely make sure you're running a modern Python version. I like using very modern features, and so if you even have 3.7, something may be broken. So yeah, make sure your Python is up to date, and I don't want to see Python 2 code. But so to start our project, we'll just make a directory for it. Typically a good idea. We'll go into that directory, and then we'll set up a virtual environment. This is something that is not super necessary, but I do recommend that you do it. We've had plenty of situations where there's package clashes or things are just not working because of your Python environment. But by creating this virtual environment and activating it, you end up in this isolated shell that is going to only have the Python packages in this environment installed. And so nothing you do in different environments will affect this environment, and so you don't have to worry about things breaking later on, or collisions for that matter. So then we're going to install the Appyter from GitHub. you can use pip install with this. It's also shown on the repository what you can use. And then we want to put this in our requirements.txt file. This is another highly recommended thing to do. The requirements.txt file just is a standard that Python developers use to maintain dependencies. And so because this is a dependency, we'll add that there and install it. And naturally, Appyter actually will already depends on Jupyter. But it turns out when you're in a virtual environment, if you do which Jupyter, the which command tells you like what binary is being used. This is actually kind of the wrong location. And so because we've just installed it, we actually have to reactivate our environment. And then if we do which Jupyter again, we see that the right path is set. So this again is the my first Appyter should be in that path since that's the name of our directory. Then finally, because we're using Jupyter, they have an extra step that we have to install a with this IPy kernel, and we can name that. And what this will do is install a Jupyter Notebook, a Jupyter kernel that will use this virtual environment. And again, it will allow you to make sure that anything installed in this virtual environment is separate from your primary system. Once we've done that, we can start our Jupyter Notebook. This sets up a web server at some arbitrary location with some randomly generated token for security reasons. Once you open that up in your web browser, you'll be able to create a new project. You should see your environment that you created. You can select that, and then you'll have a Jupyter Notebook running in that environment.
Just
finally,
a quick question. Sorry.
Yeah.
So the token is that the password prompt that you get?
Say that again?
Is the token the password prompt that you get when you open the notebook, or?
No. So the so once you open this, the token is unique so that no one can like visit your notebook from outside of your computer and use your Jupyter Notebook. And this is just generated, and once you visit this, it will authenticate you. If you were missing the token, it would say permission denied. Maybe it would prompt you for a password. Maybe it would just say, what's the token?
Is there like an option for just using a password protection?
Yeah,
or?
but it's not non-trivial. You need to like create a config file and things like that.
Right, yeah. But so right now this is not.
Yeah, this is typically the default.
Yeah, okay.
So every Appyter will start with this cell. This is the cell that activates the Jupyter magic. And I call it magic not because I'm saying, oh, it's magic. It's more because this is what these this %% in Jupyter is literally called the magic, and that's what it does. So that now this % Appyter will be registered, and then it's basically just this. All it does is makes your globals accessible to our internal function so that we can inject variables into your notebook for the purpose of making this work. So once we've set that up, we can actually start Appyter. So Appyter has a command that's just Appyter after you've installed it, and you can use the profile bio-jupys to have the pretty profile, or you can leave that to the default for the non-pretty profile. That's up to you. Then you can specify the notebook that you're using, and then here it is, it will run. So you can see that I have my two terminals. This is my Jupyter Notebook terminal, and then the Jupyter Notebook, and then here's my Appyter terminal with the Appyter. This one just comes to 5,000 by default. Both of these, the ports are configurable, but there we have it. So now that that's running, we're done. Not quite. So let's then we want to modify the notebook and see kind of how this works. Here I set up a single cell with some basic fields. Again, I use this %% code exec to instantiate the Appyter functionality, and then I'm able to write this particular code. And what's going on here is that in the Jinja, we have access to these fields. And right now we're using an int field, and the int field will be this kind of dictionary of information that we provide. The name refers to the variable name specifically on the form, and in the Jinja scope, and then with the label refers to this human readable label. The description will appear as a tooltip under this question mark in this profile, but the description may appear somewhere else in a different profile. And then the default is something we can pre-populate, but the default is also used for evaluating it now. So even though we're preparing an Appyter, which will be modified by a user later on, so they can change this number to, say, 10 and submit, and that would generate a different notebook, substituting this number for the number they provided. And basically what we do is we actually render what the code will look like given the defaults, and then actually evaluate it. So this way we can really build the Appyter and test it at the same time. And that's kind of how that works. If you have like errors, it's been set up to try its best to point out where the error is and tell you what the error is. Because we have this Jinja language, but we also have the Python language. In the past, it was a little bit confusing. I think I've clarified it. But like if you have an error in the Jinja, it appears differently than an error in the Python that's getting evaluated. But should be fixed. So now we have kind of our notebook, and here I show basically that if we put in different values and submit this, we get a new notebook with our values set up, and we actually, it gets rendered as we're looking at it, right? So right away we submit, it builds the notebook and then renders it. Then we can actually download the notebook and open it ourselves, and we'll see that we have kind of the rendered form of this notebook. So the goal here ultimately is to allow people to configure your notebook and then be able to export it themselves as a complete document. So now we'll kind of move into just building this Harmonize and ML application with Appyter. And the motivation for this is typically you'll have a Jupyter Notebook already, and then you'll want to turn it into an Appyter. And even though you can build them at the same time, perhaps building the notebook alone without Appyter is a safe bet, because you can use like Colab. I think you can use Appyter with Colab anyway, but yeah. So, but that's kind of the motivation of this section. And so given this project where we had a Jupyter Notebook representing this Harmonize and ML project where we're imputing knowledge about gene and protein function with machine learning, we have a project that looks like this. Again, we have our requirements.txt file. We have our notebook itself, We have some README and our virtual environment all set up here. And again, this is Visual Studio Code. As you can see, you can actually edit Jupyter Notebooks there as well, but that's just preference. So here we need to add Appyter to the requirements under the assumption that we already have a notebook and we already have its dependencies. We need to add Appyter and then install those requirements in our virtual environment. We also have to, again, add our initialization cell. Once we've done that, we want to start the start Appyter again with our notebook, and then, of course, right, it's empty. But now we're going to kind of look for the places where we can turn things that we want people to have configurability in. And so one of the obvious places is here in the input. We ask the user for an attribute of interest for the machine learning pipeline, and we want them to choose from some Harmonism data sets which ones we're going to be using for these data sets. And so originally I had this, this fixed list that had the data sets and would download them from Harmonism. And those are the names of those data sets. And so to turn this into an Appyter, essentially we can use a multi-choice field in this case. We can add some nice labels describing what they're supposed to be selecting. And then the default can be the same thing we chose before, while the choices are going to specify all of the different Harmonism data sets that can be downloaded by the Harmonism API. And it's very good to constrain things like this by providing choices rather than just have someone put a string field. Not least of which because of security, if they just put something random, but it will also just probably break if it's not something that's real. But by providing a multi-choice field, when we render it, we get something like this, and this allows people to shift select the form elements to select multiple things. So this is the Harmonism ML app that I have neglected to show you up till now, but this is what it looked like, and we just did the first section, but now we're going to do this next section where we actually can choose either we want to use a class as our prediction target. That is, we want to predict some feature in these, for in this case, diseases data set, or we can try and predict a gene. And so, I mean, the way this would work is we would be predicting genes that are highly associated with this class, but not known to be associated with this class, versus genes where we would be finding classes that should be associated with the gene. And so I guess I'm kind of yeah. So we need to tab between the two fields from our custom field. Sorry, we need a tab to choose between these fields, and then we also need to parse what we got in this section. So here we have cancer, and then we have the database over here. So we need to be able to parse this, but we also have this custom widget, this tabbing, which we don't have set up in Appyters. And I'll just note that what I'm discussing here is somewhat advanced. You want to use this last case scenario I may, in fact, end up modifying the way this works, but it's important to know kind of how these overrides work nonetheless, if you want to do things like just styling specifically. And so to create a custom field, the way this works is there is a bunch of set directories that are described in the documentation, but to build a field, you set up this folder next to the notebook called fields. In that folder, you add the field name as a Python file. You also need this init.py file that's empty. This is just a Python thing. Python refuses to look at directories as modules unless they have this init.py file. But when you add your target, in this particular case, we're calling it target field, and the class name should be the same as the file name. And in this field, we basically just describe in the documentation how it's supposed to be used. In this case, the target field takes choices, and then the choices refer to the tab names, and then what is at the bottom of the tab. And in fact, the vast majority of code that I'm going to put in this field has to do with the rendering, not with the actual Python side of the field. But once we've done this, we've registered the field, and it will be accessible to us in the Appyters. Like if we were modifying the Jupyter Notebook, we would be able to use this field already. The next step is to actually render the field. So you know that we set these fields, and then they end up rendering as something. So to specify that rendering, there's this templates directory, which is then, so there's templates/fields is the subdirectory. And in there you'll put target field.j2. So again, this will be the same name as your field. And in there we will put our actual rendering layer. And this is just Jinja2 HTML. So we're just using like a bootstrap style description information. And then here we're just iterating through the choices, which are the different tabs we want. And then for each of them, we'll create like the tab header with the choice name. And then we'll have the content where we'll render the actual field. Finally, we have some hidden field here, which lets us assign a value to the particular field itself, so that we'll be able to use target field when it's in a form. The next thing we want is this custom Jinja2 filter, and a filter is essentially just a function you'll be able to use in Jinja. So this is a function that the user wouldn't see after they've rendered your notebook, but you can take advantage of when you're using Jinja. And this particular function I'm just calling rematch, and all it does is the regular expression match given some target and expression. So this just allows us to take advantage of some standard Python in our Jinja. And again, this filter, once we've set up like this, function name matching the file name in this filters directory, we'll have access to this in the Jupyter Notebook with the Appyters. So now we can use these things. So we're modifying the actual notebook, and for the target, we'll have this target field with our different choices. In this case, we have a gene and a class, and the actual fields that we're using for those things, which are just arbitrary string fields in this case. And then we'll have our regular expression matcher will parse this part of the string, stat3, the identifier from the database, since that's the format of strings we are expecting. And here we're using this set notation, so this is just setting a variable in Jinja. So unlike setting a variable in Python, this variable will only be accessible when you're using Jinja. And so here we can do in Markdown, if we want to display to the user in our notebook, we can then use that variable that we extracted here. So once we've done that, we have this. It's not looking particularly pretty, but it functions, right? And we can make that look prettier all we want. All we have to do is modify that rendering layer. But for the purposes of this, it's complete. So now another thing we'll look at is, you see this customize your notebook thing. Maybe you want to change that, and maybe you want multiple sections. And to do that, you'll set up this section field. And section field just takes name, title, and subtitle. And then to make a field join a section, all you do is, once this thing goes away, you set the section at the bottom to the same name as your section field. And now that we've done this and we have our attribute, we can actually just, instead of like before doing it inline, we can have our cell with our fields and sections independent of our code, so that we don't make a mess of things. And then we just substitute the attribute data sets here into the field here. So once we've done that, we get our different sections. I added another section settings here, which we'll address shortly. And so essentially, in order to configure this particular machine learning with Harmonize and ML, we set up these choice fields where we name what it is. So in this case, select from linear SVC, and then we put the actual Python that we would have wanted here. This is different than just setting up a string field and then letting them put in whatever they want. And this is going to be, first of all, easier to work with for a person, so they don't have to know Python to use your application. But again, it's a lot more secure because we're not permitting them to put in code while we're still allowing them to configure this. And I do this for feature selection, cross-validation, and other techniques. Another feature that we can take advantage of, again, are these if and else statements. So in this particular cell, we're doing different things based on whether they've selected a class or not, and depending on which dimensionality reduction technique they've chosen. And so we can see that when we have our defaults, which was PCA, we ended up just executing the PCA parts, and we omitted this TSNE part. We can change the default in our Appyter and really play around and make sure that all of the branches are going to work properly. So the kind of final thing, or pre-final notebook, kind of looks something like this, where we had our attribute selection section that allows you to set the attributes and the targets, and then we have the different machine learning settings down here. And finally, by configuring these things and submitting, we can produce the Harmonize and ML notebook as we did in Harmonize and ML, but now instead with Appyters. So finally, I'll just talk a little about the Appyter Catalog. So we've just kind of discussed the Appyter itself, so building your own. But in terms of like integrating many different Appyters for people to use, we've set up this Appyter Catalog. And this catalog is basically just, we're going to allow people to submit their Appyters here, and we can review them, but at the end of the day, we will build them all and load them into a website. In an effort to do this, for each Appyter, we have this metadata specification file, which has a validation set up for it. So you can write your own and then make sure that it's valid. It looks something like this. And it just has information much like package.json from Node and NPM about the title, the version, description, tags, and license, things like that. This is kind of validated with the GitHub Actions. So once you've submitted a pull request to this, an automated piece of code will actually make sure that this is valid. It'll make sure that we can actually build your Appyter. So all of your dependencies are there and information like that. And finally, then the catalog interface can actually just get constructed automatically once we've merged your changes into the public version. This is, for the most part, done. This is kind of what the Appyter catalog looks like currently. We take all the Appyter JSONs for each of them and bring them together, and then we can render this web page based on that. This will definitely be improved. It was like, we built it in a day. And basically each of these are clickable. It goes to a landing page which has the README. And once you start it, you get the Appyter, which you would have seen on your own system. Then you can run it. And this supports kind of persistent notebooks. So once you've built one and run it, it will stay there, and people can visit the unique link that's generated to share it with other people or just refer to it in the future. This is all using Docker because each notebook's going to have its own unique requirements. Maybe there's some R dependencies, things like that. And so Docker allows us to properly isolate each instance and make sure that none of the packages are conflicting. In the future, we're probably going to improve the field extension a little bit to be a little more modular. And we're going to help the rendering of these to be very efficient, even if you have a very large notebook. Some of our notebooks got pretty large and would, crash your browser basically. But by using virtualized techniques, we believe we'll be able to essentially only show what you're looking at, or only render what you're looking at, and be able to render much larger notebooks on, less good computers. And then actually we're thinking possibly if other people build their own profiles or fields, we may have a separate catalog for reusing those, much like the profiles. So that's kind of it. Appyter has its own documentation. The Appyter Catalog is on GitHub and has its own website. I can show you these two. So here again is the Appyter website in the flesh, and hopefully that works. Yeah. So there's Megan's, and the actual Appyter documentation. This kind of was thrown together. This just renders the documentation from the doc strings, but hopefully it should give a decent way to browse this, so you can see the different fields over here, and basically the arguments, and I have some information about how those fields are used. Yeah. So, and you can also access the source from here if you want to see that as well. So that should, I think that's all I have for today.